2, 3, 4.
It's time to wake up.
Angles, and you're at different places on the earth, that light moves its angle to you. Look at how we just moved the atmosphere a little bit to the right, and now this light, which is over here, is being portrayed here. So you can say, well, it's supposed to set at 270 west. Well, now it's setting a little bit north of that, or it's setting a little bit south of that based on your location.
Interestingly, recreating these parallel rays with a local light source isn't particularly difficult, as we can just use a lens. You see, when the lens is placed in front of the light at the lens's focal length, it actually collimates the light rays, which means that it makes them parallel. These newly collimated rays now have some of the characteristics of the sun, namely that the light intensity doesn't change because of distance alone, and shadows don't change in size either, which is super interesting to see. Another fascinating result is that anything at the lens's focal point appears to be pinned at infinity, and appears the same size no matter whether you're close to it or far away, as we observed in my recent DIY projector project.
You can tell that it's a mirage because there is lots of distortion. The Willis Tower on the left is clearly elongated. And also, there are videos of this same view that show the buildings dancing around, changing shape, and even disappearing. Even though this is a mirage, the bottom parts of the buildings are clearly still obscured from view, just as we expect. If the Earth was flat, you could see the buildings on any clear day, not just rarely when the conditions are right for refraction. Flat Earthers use these rare events to try to prove the Earth is flat, but that makes no sense. It's called cherry picking, a favorite trick of all types of science deniers. You don't get to pick the anomalies that seem to agree with your views and ignore the common observations that don't, and still call yourself an honest investigator. That is intellectually dishonest.
Now let's see who's going to pick and choose what common observations they're going to accept and or ignore. Here's an interesting video I saw online regarding a full day time lapse revealing superior mirages. Now this is quite extraordinary actually. This is from skunkbayweather.com, September 7th, 2012. Notice the buildings and the shoreline here over on the left. Keep your eye on that. Just watch that, and the mountain in the background. Everything's pretty cool. You can see pretty much everything there, but as the day progresses, and we are now at 9:30 a.m. and it's 59 degrees, 60 degrees, it's getting warmer, the temperature is changing, we start to see some miraging take place, right? It starts to distort things a little bit. Ooh, look at that. The water seems like it's getting higher, and we're losing buildings, and we're losing the beach. Here it is now, noon, 63 degrees and climbing. Uh-oh, there it goes. Oh, there it is again. Oh, it's all miraged. Huh, it's all distorted. Sometimes you see it, sometimes you don't. The default is to see it, though. That's the point. The default is minus distorting atmospheric conditions, you would be able to see everything clearly. But due to different temperature variations and density in the atmosphere and whatnot, sometimes you can see the whole shoreline and the buildings, sometimes you can't. But the magic trick is not in being able to see it. It's what is taking place that obscures your ability to do so. Look at this. And the mountains in the background shrink and expand and everything too. You know, I would suggest that you hit pause on this video and rewind and watch that back and forth a few times. In fact, I'll put the link in the show notes below because I sped this up. I made it only 2 minutes long instead of 4 minutes long. So you can watch the whole thing in a little bit slower motion there. But I mean, look at the comparison right here, just in these two images right here. The one on the right at 5:44 p.m., 63.5 degrees Fahrenheit. Can't really see anything on the left shoreline there. And on the left at 9:43 a.m., when it was 59.5 degrees Fahrenheit, we can see the shoreline, we can see buildings, trees, all kinds of stuff. So, I mean, either this lake is, you know, filling up and draining so that the water level is higher or lower, or it's due to atmospheric lensing and distortions, refraction, and all that good stuff, causing us to not be able to see it at certain times. I think that's exactly what's going on Lake Michigan. And again, based on that imagery that I saw looking 46 miles across versus 0.6 miles across, I really do believe that, just like the experts said, the globalist guys, these are people who believe in the globe now. They are the ones that said, hey, the atmosphere really is acting like a lens, and they put a lens in front of the camera to show how it works. So I'm just doing what they're doing. I'm using the same logic that they're using, the same science that they're using. And science is all about testable, observable, and repeatable data, right? So to alleviate the problem of distorting the edges because the magnifying glass ring is too small, I went on Amazon and I got these plastic magnifying sheets and came up with another way of doing the same thing, using the sheet right here. Set the city up, a little cutout of the city, and now I've got the big magnifying glass sheet. Bring the camera right up to the lens. See, that's the normal view of the city. Now let's back up again.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here,
The atmosphere really is acting like a lens.
yes.
Atmosphere really is acting like a lens, and this is how much of the city is missing due to the lensing effect, the magnification of the atmosphere. You're missing a good portion of the city just by pulling my iPhone back on a 3-foot long desk. That's how much I lost of the city. And as with any scientific experiment, you always try to improve upon what you did before. So I got some foam core, made a little housing for the magnifying sheet, and pasted the city on the back there, and I made it as 2 separate pieces so that I could flex it as necessary, because I think that there are different types of atmospheric conditions that would allow for more magnification versus less magnification. So in this scenario you have more magnification, and in this one you have less. And for this one I decided to put the Toronto skyline into my little box here. And let's try it again. Okay, we're all the way up against the glass. Now let's zoom across the lake. And wow, look at that. The lower portions start to disappear. Now let's zoom back in to get a little closer to the one that Captain Baltard was talking about here. And wow, look at this. Here's his image on the right, and here's my image on the left. Missing the lower portions of the city had nothing to do with curvature whatsoever.
This magnifying glass represents our personal atmospheric dome by which we view celestial phenomena in our world. Believe it or not, everything we see is magnified by the water particles in the air. And so we're going to start over the North Pole, which is where Polaris is, the center of the flat Earth. And you can see as we go south, even though these are circles around the North Pole, it actually creates kind of a fictitious southern pole star there as we move out from the north, which would be south. You can also see how if you were in the north, you would see the moon right side up, and if you're in the south, you would see it upside down. And as these stars do circles around us from east to west, you can see how in the south they would appear to be rotating in a counterclockwise direction as opposed to north.
We all know that the stars rotate counterclockwise when looking at the north, and so you get the confusion of people saying, well, what about the south? They rotate the other ways. Well, let's watch. You can see that they lift to the upper right, going up that wall, counterclockwise. So let's keep following that. Remember that, up this wall, up the wall. Keep rotating to the right, up the wall, keep going a little bit more, up the wall, up the wall. We're getting towards the south, they go up the wall. Look at that. Now they go clockwise. That's all it is. There is no southern pole star. They're all rotating the same direction. It's like a big tunnel rotating above us.